In this video, we will be focusing on the unit circle and circular functions. For those of you who took trigonometry in high school, a lot of this section will be familiar. And those of you that are enrolled in trig for the first time this semester, this will be somewhat repetitive from the previous two chapters that we've been looking at. What we're doing now, and we've sort of been alluding to this all along, is we're taking all of the ideas we had about a triangle and we're transposing them onto a circle. Now, in this particular case, the circle is going to be special in that it's going to have a radius of 1 unit. And so you can see on the x-axis, for example, that the coordinates at the ends of the circle are 1, 0 and -1, 0. And then similarly, on the y-axis, the coordinates are at 0, 1 and 0, -1. At any particular point that we look at on the circle, we can draw a triangle, as we've done previously, where this side would be the x-coordinate, this side would be the y-coordinate, and then the radius is this part here. And so this relationship that's shown down here at the bottom really is just the version of the Pythagorean theorem where we're taking the two sides and squaring them, and then taking the radius and squaring it. Because the radius is 1, you just end up with 1 on that side. These are going to be called circular functions because they're sitting on a circle. And the other thing that we're going to have that's slightly different is that when we, instead of thinking about an angle based on a particular triangle that's drawn, we're thinking about an arc that has been created, right? And so the length of that arc is also related to the angle that is open from the initial side to the terminal side. Now, when we had a triangle that was drawn, we had the relationship that the cosine of the angle was, say, x over the hypotenuse, or the sine was y over the hypotenuse. But because the hypotenuse is just equal to 1, we can eliminate that h in the denominator, and we get these relationships where x is actually going to be the cosine of the angle and or the arc length, and then y is going to be the sine. So we can see that reflected in these new definitions that we're using. Again, S is taking the place of the arc length, or it would be the same as what in the past we were using as the angle, right? And we would have had y over h, but because h is equal to 1, we'll just have y instead. And then similarly here, we would have cosine of theta is equal to x over h, but h is equal to 1, so we just end up with x. Take note that, as before, when we look at cosecant, secant, and cotangent, the denominators can never be equal to 0, because that would cause a fraction that is undefined. Now, on Canvas, you'll see that there is a copy of the unit circle that's been posted. And the key components for any unit circle are the measurement of the angles in degrees, the measurements of the arc lengths in terms of radians. We'll get to that in just a second, changing back and forth between radians and degrees. And then these values are the x and the y coordinates for a particular point. But again, they also relate to the cosine of the angle and the sine of the angle. And so in a traditional class when we are not online, we would have students memorize all of these. I want to show you a couple key features about values that are on the unit circle. So there is a couple different forms of symmetry that exist. So let's take this point and this point. When I look at those two values, the x and y coordinates are the same, with the exception that Over here, we've got a negative x value, right? And that's because of where that point is in relation to the origin. If I were to draw a triangle based on the angles that are associated here, they would look like this. And so this angle is the same as this angle. This angle here is 30 degrees. This angle here is also 30 degrees, which is how we're getting to the overall measurement of 150 degrees. Now, if we were to look at that in terms of radians, one thing to notice is that the radians both have a denominator of 6, pi over 6 and 5 pi over 6. The other places where there are denominators of 6 is here, 11 pi over 6 and 7 pi over 6. And similarly, if I were to draw a triangle to these particular points, this angle here would also be 30 degrees, or pi over 6, right? Pi over 6 is equivalent to, is equivalent to 30 degrees. Remember that pi is the same as 180 degrees, and so when we divide that by 6, we get 30. And so we've got this symmetric nature that crosses the x and the y-axis, and then also goes about the origin, meaning that if I take a point here and I spin around the origin 180 degrees, the coordinates are the same. The only thing that changes is the positive and the negative based on what quadrant it's in. I have that same idea for, let's say here, pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Again, these are all going to be triangles that are identical, just in different locations, like this. Remember that the right angle is always sitting right next to the x-axis, and then the angle is sitting right next to the origin. Okay. This table is a mathematical way of thinking about how these functions are related. I think it's easier, for me, it's easier to see it in picture form. But what this is saying mathematically is that if I'm thinking about trying to remember where a particular measurement is, let's say 2 pi over 3, that I'm going to go from the x-axis in that same quadrant. The x-axis in that quadrant is here, so that would be pi. And I'm going to subtract what ends up being the reference angle, right? So pi over 3 to get to that 2 pi over 3. If I were instead thinking about the angle over here, which is 5 pi over 3, the x-axis in that quadrant is here, and to get to that particular point, I would be going from 2 pi, and then also it's this pi over 3 is this angle here that's being subtracted to get back to this 5 pi over 3. I think it's easier to think about this, like I said, just in terms of the symmetries, and remembering that when I'm over, let's say, in the second quadrant, I know that the terms are going to be negative for the x value and positive for the y value. And so if I memorize everything in the first quadrant, I can get the other things, the other quadrants, quite easily just by changing the signs. We talked about this as far as the Pythagorean identity, but because we are now defining x to be the cosine of s, and we're defining y to be the sine of s, exchanging those into this Pythagorean identity, we get that the cosine squared plus the sine squared is equal to 1. And this is the first Pythagorean identity, and we'll use this a lot in the upcoming weeks. So that's all that you need to know for this particular section. The next section is looking at linear and angular measurements, linear and angular speed. All right, have a good day, and I will see you in class.